Prompt engineering versus programming became very real for one team after a coding agent cleaned up a repository. The prompt said, in plain language, never delete user files. The model still proposed a command that removed generated artifacts, and because the repo layout was weird, 38 real files went with them. Everyone blamed the prompt. The real bug was that deletion policy lived in prose instead of code. There was no allow list, no path validator, no dry run gate. A must-always rule was sitting inside a maybe-follow instruction. The naive approach treats the prompt like a program. Add more bullets, add uppercase warnings, add a paragraph that says always do this and never do that. Sometimes that improves behavior, but it does not create a contract. Language models are probabilistic judgment engines. They compress context, infer intent, and sometimes choose the wrong trade-off. In a loop, one soft miss can become a real side effect. A bad file edit, a wrong email, an invalid API call, or corrupted state. Then retries can make it worse, because the same weak boundary is crossed again with slightly different wording. Here is the pattern. Prompts steer judgment. Code enforces contracts. If something must always happen, it belongs outside the prompt. The model can decide which paragraph is relevant, which test failure matters, or which search result looks credible. Code decides whether the output is valid JSON, whether a path is inside the workspace, whether a budget is exhausted, whether a tool is allowed, and whether a state transition is legal. My opinionated rule is simple. Never ask the model to enforce your invariants. You can ask it to explain them, but code has to check them. Mechanically, wrap the model like you would wrap an untrusted service that is useful but not authoritative. First, sanitize inputs, normalize encodings, trim size, redact secrets, and remove fields the model does not need. Second, prompt for the judgment you want, with examples when useful. Third, require structured output, fields, types, enums, and reasons when you need auditability. Fourth, validate the output against schema and business invariants. Fifth, only execute tools after validation passes. If validation fails, repair once or twice with explicit errors, then fall back. Log whether the failure was prompt quality, model capability, schema mismatch, or invariant violation. Take a content pipeline that turns a transcript into a title, summary, slug, and publish record. The bad version says in the prompt, make a safe slug, keep it under 60 characters, never reuse a slug, and never publish without a description. That will fail eventually. The reliable version lets the model propose a human-friendly title and maybe a slug candidate. Code lowercases it, strips unsafe characters, limits length, checks the database for uniqueness, and appends a suffix if needed. Code verifies the description is present before publish. The prompt provides taste. The pipeline provides guarantees. This pattern is not magic. You can still encode the wrong invariant. You can make a validator so loose that nearly anything passes, or so strict that useful work gets rejected. Repair loops can hide a design bug by repeatedly asking the model to satisfy an impossible contract. Structured output does not mean truthful output. It only means parsable output. For factual claims, you still need retrieval, citation checks, tests, or external verification. Also, some choices really are policy choices, not pure code. In those cases, define the policy in code as a decision table, or route uncertain cases to a human. This idea connects to almost every foundation topic in loop engineering. Stop conditions are code, not vibes in a prompt. Budgets are counters, not requests for restraint. Tool permissions are allow lists, not polite instructions. State transitions are state machines, not paragraphs asking the model to be careful. Verification is a separate layer, not the same model confidently grading itself without evidence. Prompts still matter. They reduce ambiguity and improve judgment. But reliability comes from deciding where determinism lives. If a loop is flaky, ask which requirement is pretending to be a prompt when it should be a program. Here is a 10-minute exercise. Pick one automation you already use, even a tiny one. Open the prompt and highlight every phrase containing always, never, must, only, do not, required, or valid. For each phrase ask, can code check this after the model responds? If yes, write the check as a validator. Start with one rule: length limit, allowed file path, required field, approved recipient, maximum spend, or enum value. Add a log line that says which validator failed. Do not rewrite the whole system. Move one must always rule out of prose and into code today. Recap in 3 beats. First, prompts are not programs. They are steering for a probabilistic judgment engine. Second, anything that must always happen belongs in code. Sanitizers, validators, allow lists, budgets, state machines, and publish gates. Third, flakiness often means determinism is in the wrong layer. Move contracts outside the model, then let the model do what it is good at, interpret messy inputs, and propose useful choices. This is episode 33 of Loop Engineering, in the Foundations tier. New Loop Engineering episode daily on this channel, moving from small reliable loops to fleet-scale systems.